You carry a number in your head, a piece of cosmic graffiti. It isn't yours. It was burned into you, scrawled across the inner wall of reality. You think you know what it means? A speed limit, a cosmic law, the fastest anything can possibly go. But you don't, not really. You've never felt it. You've never touched it. The number is 299,792, 458 meters per second. A flash, a blur, the edge of the known map. But what happens at the edge? What force holds you back from crossing it? Is it a wall of crystal? A cosmic friction? A divine decree? You've been told it's a law, and you accepted it. Like a child accepts that the sky is blue, without asking what blue is. But that is not an answer. It is a surrender. To ask why is to find a loose thread on the tapestry of existence. To pull that thread is to watch everything unravel. The floor beneath your feet, the clock on your wall, the past in your memory. Because the answer has nothing to do with going fast, and everything to do with the very substance of time itself. The speed of light is not a speed. It's the price of existence. And paying attention to its true cost will change you. Forever. The story we tell ourselves is a simple one. A comfortable nursery rhyme for a species born in the slow lane, a fable to make sense of our world. You're on a train, the carriage smelling faintly of steel and dust. The rhythmic clatter of the wheels a steady heartbeat as it moves at 50 miles per hour. You throw a ball forward at 10. To someone watching from the quiet stillness of the platform, the ball blurs past at 60 miles per hour. Of course it does. Speeds add. This is the first rule we learn. It's a truth felt deep in our bones in the sinews of our animal past. A logic born of mud and muscle, of throwing rocks at prey and running from predators under an ancient sun. It's a planetary truth, a local bylaw for our plodding terrestrial experience. But it is not a cosmic truth. It is a rounding error. It is a profound and comforting illusion. Out there, in the silent, sprawling, ink-black dark, our simple addition is a child's crayon drawing of a universe that is infinitely more elegant and terrifyingly more strange. To find the real rule, we can't start with a train or a flashlight. We must go back to a colder, quieter time. We must stand beside a man staring at the heavens, utterly convinced the universe's clock was broken. Our journey begins not with light, but with gravity. With an apple, yes, but that's the myth, the sanitized story. The truth is, in the moon, a silent, pockmarked God in the sky. An object of impossible size, forever falling yet forever suspended in the night. It is a paradox hanging over our heads every single night, and one man decided to resolve it. Imagine England in 1665. The air is thick with the smell of wood smoke and dread. Houses are marked with a red cross, a sign of the pestilence within. A great and terrible silence has fallen over the cities. In this forced solitude, a young Isaac Newton stares out his window, not at an apple, but at the moon. He sees it not as a celestial lamp, but as a projectile. A cannonball, fired with immense force, falling. He watched that eternal, silent plummet from his window in a plague-ridden England. He saw the moon, pulled inexorably by the earth, but moving sideways just fast enough to always miss. A celestial dance of fall and flight. From this cosmic ballet, he forged a law, an inverse square law of exquisite, terrifying simplicity. Gravity's grip loosens not by half, but by the square of the distance. It was a weapon of prediction. This one law bound the falling apple to the orbiting moon, the tides of the ocean to the pull of that distant rock. It explained the elliptical paths of the planets, transforming Kepler's meticulous observations from raw data into understood physics. Newton's law was no longer a mere theory. It became a lens, a new way to see reality. It was a baseline of truth so powerful, so certain that if the universe seemed to contradict it, the flaw was not in the law but in your understanding. And in 1676, a ghost appeared in the machine. A Danish astronomer named Ole Rømer, working in the new Paris observatory, found a flaw in the cosmic clockwork. The air in the observatory was likely cold, smelling of tallow candles, wet wool, and old paper. He was timing the eclipses of Io, the innermost Galilean moon of Jupiter. A tiny, predictable clockwork in the sky, a celestial metronome he hoped sailors could use to find their longitude on the vast, featureless, and deadly oceans. A reliable clock was a matter of life and death, of fortunes made and lives lost. But the clock was wrong. It was dangerously, maddeningly wrong. Io was not on schedule. Sometimes its disappearance behind the colossal disk of Jupiter came minutes early. 6 months later, it would be minutes late. The total discrepancy was a staggering 16 minutes and 40 seconds. For Newton's perfect godlike law, this was a universe-breaking error. It implied the planets themselves were speeding up and slowing down for no reason. It was chaos where there should have been order. For Rømer, it must have felt like a personal failure, a betrayal by the heavens he so carefully observed. But Rømer felt the truth of Newton's gravity in his marrow. He trusted the cold, hard math on the page more than the flickering light hitting his eye. He noticed a pattern, a quiet rhythm to the error. The moon was early when Earth, in its orbit, was closest to Jupiter. The moon was late when Earth was on the far side of its orbit, across the sun. The error grew and shrank with a perfect, predictable harmony. A harmony that matched not the motion of Io, but the motion of Earth itself. The distance was the key. The distance. The enormous, empty, silent void between the worlds. That was the only variable that matched the pattern. A thought must have struck him then, a thought cold and brilliant as the stars outside his window. It's not the moon that is late. It is the message. The light itself is delayed. He understood with a sudden chilling clarity that the light from Io did not arrive instantly. It had to cross the unfathomable gulf of space. When Earth was farther away, the journey simply took longer. The light arriving at his telescope was old news, a postcard from a past event. The ghost in the machine wasn't a flaw in gravity. It was the travel time of light. He realized he was not watching Jupiter as it is, but as it was, 16 minutes ago. The universe, he saw, is always a memory. By measuring that systematic lateness and knowing the diameter of Earth's orbit, Rømer did something no one had ever done before. He measured the speed of light. He didn't point a device at a beam. He took the measure of the cosmos by having unshakable faith in a completely different law. This is the first tremor of the avalanche. A truth, once discovered, becomes a tool for finding the next, much larger truth. The law of gravity, born from watching the moon, had just given us the speed of light. And that number would, in turn, give us an entirely new universe. For 2 centuries, this number remained a curiosity, a property of light, nothing more. Then, in the smoky industrial heart of Victorian Britain, a Scottish physicist named James Clerk Maxwell began to play with the invisible world. He sought to unite the crackle of static electricity and the silent ghostly pull of magnetism. He smelled the ozone of a spark gap, felt the strange resistance of magnets pushing against each other through empty air. He wanted to write the rules for this unseen ocean of force that surrounded him, to capture its essence in the pure, cold language of mathematics. He described the chaotic, humming riot inside a piece of copper wire, the unseen forces that snap compass needles north, a river of influence flowing from the Earth's molten core. He wove the disparate equations of these two phenomena, electricity and magnetism, together into four elegant, powerful statements. It was a unified theory of electromagnetism, one of the greatest achievements of human thought, a symphony written in the language of mathematics. And then something happened. A detail emerged from the math, an unexpected consequence, a prophecy written in the ink of his own equations. As he worked through his own equations, a number fell out, a speed derived purely from the properties of electricity and magnetism, the permittivity and permeability of free space. It was a speed required by the internal logic of the universe he had just described. This number represented the propagation speed of a wave through this new unified electromagnetic field. The number was 299,792,458 meters per second. It was Römer's number. It was the speed of light. He had found it again, not in the sky, but hidden in the equations for magnets and sparks. Light, he realized with a shock that must have felt like a religious revelation, was this wave, a ripple of pure electromagnetism traveling through the void. It was the same phenomenon as the invisible force that turned a motor, or the static that made your hair stand on end, just vibrating at an incredible frequency. But this profound discovery concealed a seed of absolute madness. Maxwell's equations were rigid, unyielding. They declared that the speed of this wave, light, was an absolute constant. It wasn't relative to anything. It was just scare always. It didn't care if the source was moving toward you or away from you. This should feel deeply, fundamentally wrong. It should scream against every intuition you have. If you are on a train moving at 100 miles per hour and shine a flashlight forward, the light speed should be its own speed, plus the train speed. But Maxwell's perfect equation said no. The answer is always just 6 ina. Always. For decades, the world's greatest physicists threw themselves at this paradox. They couldn't accept it. It broke their world. They invented a fantasy substance to save their familiar reality. The luminiferous ether, a massless, invisible cosmic jelly that filled all of space, the medium through which light was meant to travel. Your speed relative to this ether, they argued, would explain the discrepancy. But every experiment designed to detect our motion through this cosmic jelly, most famously the Michelson-Morley experiment in a quiet basement in Cleveland, failed. They floated their delicate interferometer on a giant pool of mercury to dampen vibrations. They expected to see a shift in the light pattern, a tiny change in the interference fringes, as the Earth rushed through the ether on its journey around the sun. But there was nothing. No matter the time of day, no matter the season, the result was null. The light did not care. The ether wasn't there. The universe was whispering a terrible, beautiful secret, and no one was brave enough to listen. No one, that is, until a young man in Bern, Switzerland, a patent clerk who spent his days reviewing schematics for mundane machines and his nights imagining riding on a beam of light. His name was Albert Einstein. He wasn't a tenured professor. He was an outsider, unburdened by the dogma of the establishment. He saw the failure of the Michelson-Morley experiment not as a problem, but as the answer itself. The universe wasn't broken. Their assumptions were. Einstein performed the ultimate act of intellectual courage. He stopped trying to fix the paradox. He embraced it. He built a church on it. He proposed two simple postulates, the second of which was this. The speed of light in a vacuum is the same for all observers, regardless of their motion. From this single brain-breaking assumption, a new reality bloomed. If speed is distance divided by time and the speed of light, c must remain the same for everyone, then something else has to give. That something was the solid, dependable bedrock of existence, space and time. They could no longer be absolute. This is the heart of it. The moment your old brain breaks and the new one is built. To preserve the constancy of light speed, the universe performs a conspiracy. As you move faster through space, time itself begins to flow more slowly for you relative to a stationary observer. Your clock, your heartbeat, the chemical reactions in your brain, they all slow down. This isn't a psychological feeling of time dragging like a boring lecture. It is a physical, measurable change in the rate at which you move into the future. Time literally dilates. It stretches like warm taffy for a moving object. At the same time, the universe conspires in another way. Space in your direction of motion contracts. The meter stick you carry, if measured by someone you fly past, would be shorter. The distance to your destination physically shrinks from your point of view. Time dilates and space contracts in a perfect, synchronized cosmic plot. And the purpose of this grand conspiracy? To ensure that when anyone, anywhere, at any speed, measures the speed of a beam of light, the ratio of the distance it travels over the time it takes always equals Xinang. It's not a theory about light. It's a theory about the very geometry of reality itself. Space and time are not a fixed, rigid stage on which the play of the universe unfolds. They are a single, dynamic, malleable fabric, space-time. And the speed of light is the thread count of that fabric. It's the conversion factor between the meter and the second, the secret exchange rate that binds them together. Here is the Feynman bridge, the analogy that makes the impossible click into place. Imagine you are always moving through this four-dimensional space-time. Your total speed is constant. You are always, right now, traveling at the speed of light. This is your birthright. This is your state of being. But that motion is divided across 4 dimensions, 3 of space and 1 of time. Right now, sitting still in your chair, almost all of your motion is directed purely through the dimension of time. You are hurtling into the future at the maximum possible rate, 1 second per second. Your speed through space is 0. The moment you start to move, you stand up, you walk, you get in a car, you divert some of your motion. You have to trade some of your velocity through time to gain velocity through space. You have a fixed motion budget through space-time, and that budget is always, immutably, CCU. You can't get more. The faster you travel through space, the more of that budget you must steal from your travel through time. Your clocks slow down. You age less than someone standing still. Your total velocity through space-time remains pegged at ECCs. But the allocation has changed. You are sacrificing your future to move through the present. This is why you can never reach the speed of light. To travel through space at ease would require you to divert your entire motion budget to spatial movement. you would have to allocate 100% of your motion to space, leaving zero motion left for the time dimension. Time would stop for you entirely. Your personal clock would cease to tick. From your perspective, you would arrive at your destination at the exact same instant you left. But to go faster, it would require you to have more than 100% of your motion budget. It's a geometric impossibility, as absurd as asking to go north of the North Pole. The question isn't about engineering a better engine or finding a magical fuel. It's about violating the fundamental geometry of what to move even means. The universe is not forbidding you. It is telling you that your request is meaningless, a grammatical error in the language of physics. So, what about light itself? A photon, a particle of light, is a special case. It has zero mass. This means it has no choice in the matter. It cannot be at rest. Its entire existence is spent traveling at this through space. It uses its entire motion budget on spatial travel from the moment of its birth. This means a photon has zero motion through time. From a photon's point of view, its creation and its absorption, even if separated by billions of light years from our perspective, happen in the same instant. For a photon, the universe is a flat, timeless photograph. There is no past. There is no future. This isn't a mind game. It's not philosophy. It is the brutal physical reality we live in, and our civilization depends on it every day. The GPS satellites orbiting high above us are our constant, silent proof. They are moving very fast relative to us, and they are in a weaker gravitational field. Their internal atomic clocks, which count the frantic 9 billion times per second vibrations of supercooled cesium atoms, tick about 38 microseconds faster than ours on the ground each day. A microsecond is a millionth of a second, a tiny, insignificant amount. But it is real, and it accumulates. If the engineers did not program Einstein's equations into the GPS network to correct for this time dilation, the entire system would fail catastrophically. The errors would compound with every passing second, a creeping tide of temporal chaos. Our carefully constructed world of precision would dissolve. Within a single day, your phone's map would be off by nearly 7 miles, guiding a self-driving truck into a river, convinced it was a highway. Global financial markets, synchronized by GPS time, would descend into chaos as trades arrived milliseconds out of sync, erasing fortunes. Our world is held together by a relativistic correction. We see it in our colossal particle accelerators, the cathedrals of modern physics. In a 27-kilometer ring buried under the French and Swiss countryside, we take a single proton and, with the energy to power a small city, accelerate it to 99.9999991% the speed of light. Yet each new 9 we add to that decimal requires exponentially more energy than the last. We are pushing against a wall that gets infinitely hard. It's not friction. It's the particle's own inertia. Its mass, which increases as it approaches. See stuns. Mass and energy, Einstein showed, are two faces of the same coin. We are feeling the texture of space-time itself, resisting the change. To push that proton over the final, infinitesimal gap to 100% would require infinite energy. The universe says no, not by building a wall, but by making the journey infinitely long, demanding an infinite price for that last sliver of speed. We see it in the constant gentle rain of cosmic rays. Tiny unstable particles called muons are born in the violent collisions of cosmic radiation with our upper atmosphere. They have a brutally short lifespan, just 2.2 microseconds. They are ephemeral ghosts, born to die almost instantly. Even traveling near light speed, they should decay, dissolving into other particles, long before they can travel the 10 kilometers to the surface. Their short life should end high in the stratosphere, a brief flash of energy unseen from below. Very few, if any, should reach us. But they don't. We detect them here on the ground, in droves, passing through our bodies every second. Why? From our perspective, their frantic internal clock is slowed by their incredible speed, extending their life by a factor of 10 or 20, long enough to complete the journey. Their 2 microseconds become 20. From the muon's perspective, its lifespan is perfectly normal, a fleeting 2.2 microseconds. But the atmosphere itself, the miles of air between its birth and the ground, has contracted due to its speed. The journey becomes a short dash it can easily complete. Both views are correct. Reality conspires to be consistent. The speed of light is not a barrier. It is a consequence. It is the maximum rate at which cause can precede effect. It is the speed of now, rippling outward from every event in the universe, defining the boundary between what can affect you and what cannot. It is the speed of causality. To travel faster than light would be to receive an answer before you ask the question. It would be to see the shattered glass on the floor before you hear the sound of it breaking. It would mean a bullet could arrive before the gun was fired. It would rip apart the logical fabric of cause and effect. Our universe is a story. It has a beginning, a middle, and an end. The speed of light is the rule that says, you cannot read the last page first. It enforces the narrative structure of existence, preventing reality from descending into an incoherent, paradoxical mess, where everything happens at once and nothing makes sense. The avalanche of discovery that began with Newton watching the moon, that gained momentum with Roemer trusting a law over his own eyes, that exploded with Maxwell finding a ghost in his math, and was finally understood by Einstein imagining a ride on a light beam, is the story of science itself. Each truth a foundation for the next. We have been avalanching for 400 years. We started by trying to understand cannonballs and ended up with a cosmos where time bends, space shrinks, and your motion through the world dictates your journey into the future. We didn't just find a law, we discovered the very grammar of reality. The universe is not a collection of things, it is a sequence of events. And the speed of light is the rule that dictates that sequence. It is the loom on which the fabric of space-time is woven, the fundamental rhythm that gives our universe its structure, its history, and its future. So the next time you see that number, 299.792, 458, don't just see a limit. See it as a Rosetta Stone. The secret ratio that binds space to time, energy to mass. It is not a wall that says you cannot pass. It is a signpost, pointing toward a truth far stranger and more beautiful than we ever dared to imagine. It tells you that you are a traveler, not just through space but through time. It tells you that every second of your life you are moving at the one true speed, the only speed that matters. You are moving at the speed of light, and your only choice is which direction to point. If you could take a one-way trip on a starship traveling at 99.9% the speed of light for what feels like 1 year to you, knowing you would return to an Earth centuries in the future, would you do it? What truth about humanity do you think you'd discover upon your return?